This question belongs to Theory of Computational Subject and was asked in GATE CSE 1987. The topic name is Context-Free Language. So the question asks whether the intersection of two CFL is also a CFL, if it's true or false. We know CFLs are not closed under intersection, which means the intersection of two context-free language may or may not be a context-free language. So the answer is false. Let me give a contradicting example. Suppose we assume that the intersection of two CFL is always a CFL. Now we can easily contradict this statement. Let L1 be a language given by a to the power n, b to the power n, c to the power m, where n and m is greater than or equal to 1. As here we need to compare just whether A and B are equal or not, thus it can be done using one stack and is a context-free language. Let us consider another language L2, which is defined as A to the power n, B to the power m, C to the power m, for n and m greater than or equal to 1, as we have to compare just whether the number of B's and number of C's are equal or not, which can be done using one stack, thus this is also a CFL. Thus L1 is a CFL and L2 is also a CFL. Now let us find the intersection of two languages, L1 and L2, which is equal to a to the power n, b to the power m, c to the power m, for all m is greater than or equal to 1. As here we need to compare whether the number of a's and number of b's are equal and whether the number of b's and number of c's are equal. Thus it has more than one comparison, it has two comparisons. Thus it cannot be done by using one stack or by using a context-free language. It's basically a context-sensitive language. Thus, we have arrived at a contradiction that the intersection of two CFL is not a CFL. Thus, CFLs are not closed under intersection, and the intersection of two CFL may or may not be a CFL. Thus, the answer is false.